All right, well, today we'll be talking about server-side rendering React.js components. A little bit about me. I started a custom software and consulting company about 5 years ago, and I've been doing that with Taylor, one of my coworkers right over here. I've been a full-stack developer for about 5 years, and I've been creating and maintaining isomorphic or universal, however you want to say it, JavaScript applications for about the last 2 years. So today, just kind of a quick agenda. I want to go over some of the pain points and why server-side rendering looked interesting to me. Some basic examples of client-side rendering and server-side rendering. And then a third example to kind of bring it all together, data hydrated server-side rendering example, and then just kind of some high-level overview stuff. So some of the pain points that we were having at RAD is our current code bases were really complex. We didn't know what stuff was rendering on the server side. We didn't know what was rendering on the client side. Everything started to get just a little weird. We had multiple languages in our projects and multiple test frameworks, which really didn't make it ideal. And new developer ramp-up time for developers to come on projects really started to slow down. Projects needed SEO compatibility. So in order to be successful, search engines needed to crawl our web pages, and this wasn't ideal using client-side rendering methodologies. And then the third thing is we really wanted to write backend and front-end JavaScript. So we really wanted to make our apps universal, and basically that would cut down on the differences between relevant projects. So we really wanted some uniformity in our JavaScript projects. So I'm going to go into two examples. First I kind of want to just go over the couple differences in the two examples that I'm going to explain, which is client-side rendering and server-side rendering. So the first method that's kind of different that you may have used if you do server-side rendering techniques is React DOM server render to string method. So this method returns HTML markup, and you're able to inject this into your HTML document before you send it down to the user's browser. Basically, this markup is going to match exactly what React DOM render is going to generate. The second method, you guys are probably all really familiar with this, rendering a React component or a single page application. And then this new method just actually came out in React 16. And this is specifically for server-side rendered markup. It's called Hydrate. So it's pretty much the same thing as rendered, except it doesn't actually recreate your markup in your application container. So your div root. It actually just binds event handlers, which gives it a little bit more performance because it doesn't have to render your whole application. Okay. So these two guys are side by side. So I just used a basic Express.js project, and I kind of inlined everything in the router just so you guys could see what I'm talking about. So for the first example on the left-hand side, we have a client-side rendering example, and then is there any way I can move this guy? And then on the right-hand side, we have a server-side rendering example. So both of these examples are pretty much the same, but you only see a couple differences in them. So in the client-side example, let's say I want to set a title and a description for SEO purposes, and then you really just declare your application container and obviously your JavaScript bundle. So the HTML stays really static for almost every page that you're going to be rendering. And then on the server-side rendering example, it just has in addition a couple things. So the first change is we're using React DOM server render to string. So whatever we're going to be rendering on the client side, we want to generate that on the server side first. So we're going to use that method to create the HTML markup and actually inject it into our HTML document to send it down to the user. So the other difference is that HTML markup string is actually put into our HTML document to send down to the user. And then, how many of you guys are really familiar with Webpack? Okay, good. Because honestly, I use Webpack extensively, and I'm not really sure if you can do some of these techniques without it. Keeping your bundle sizes down to minimum sizes really helps this, and I'll kind of show you why at the end. But the other differences are in your client-side entry point that your browser is going to be rendering. Your client-side example just uses your React render function, and then your server-side rendered example uses the new hydrate method. So it's only going to be event binding that server-generated markup. So I'm not sure exactly how well this is going to work up on these screens. But so this, for the client-side rendering example, this is what search engines can see. And it's not really too helpful if you have really critical content that needs to be crawled by search engines, especially if it's, if you're running a content-based product. The second example, that source, it actually has the component or application that you want to render. That markup is actually already pre-filled into your application container. So if we check this out, I didn't have time to really push this up to a live environment. So I'm throttling the network a little bit so you can kind of see what I'm talking about. But basically, you see this white screen as your bundle is being downloaded. And then once your bundle is downloaded, React executes your application. And then your API call goes out to populate your data. So you kind of saw that. I'll kind of do it again. But that white flash, so there are definitely ways to mitigate those by loading screens and whatnot. But then your user is loading. It's not that cool. So example 2, since the markup is already being sent down in the document, it can already be rendered instantly as long as you send everything in the document that you want. So if I refresh this, so you didn't see the white flash because the HTML markup is actually there, but the data didn't come in until the component actually, or until the bundle was downloaded. Your component was executed by React, and then the API call would go out. So to kind of bring that all together, there's kind of this third example I'm going to show that kind of brings in the best of both worlds. So it's basically initial data hydration with server-side rendering. And instead of initially fetching your data with an API call once your application mounts, you can actually just send it down with your component or application that you render inside the container. So the document size is bigger, but it should be much shorter than downloading and waiting for your JavaScript bundled. Yeah.
I just want to understand. So what you showed us until now, the last one,
yeah.
You see a loading screen right away, which is better than nothing, but you still haven't shown us the full thing, right? Like,
Yeah.
it's still not good for SEO.
Depending on what you're showing. So since my demo app is so small, the markup like isn't very great. But yeah, so exactly. Yeah, so in example 2, inside of your application container, you actually have the application that I made. It's so simple though, because it's it's an H1 and a UL. So
But so you would have the H1, but it still says loading. Like if you have.
yeah, so critical data that you may want. So like it's basically initial state hydration, which I'm going to get into right now. Basically, I'm just trying to ease into the idea of server-side rendering, and then we're going to kind of go into it. Yeah. So now that we're kind of comfortable with how server-side rendering works, let's start initially hydrating our application with some data. So from going to a server-side rendered example with a hydrated server-side rendered example, it's not that big of a change. So again, everything's in the router, just to kind of show you this. So basically, you have your API call to fetch your critical data from your database that you want to display in the HTML document. So that takes a little bit of time. And then rendering the actual server-side HTML markup takes a little bit more time. But the trade-offs are it should be much faster than downloading your entire JavaScript bundle before to fetch that data. So the biggest differences are your API call. You're initiating initial props that you want to hydrate or inject into your component or application. And so you'll see React DOM server rendered to string is actually injected with the initial props that I got from my database. So the blogs with a title and description. And then the HTML markup is almost the same as far as comparing these two, but you also have to put the initial props into like a window property, because even though the markup is sent on the server side, your application has to execute on the client side and match that markup that your server side rendered. So I stuffed that into something called app props. And so you just put in your app string just like you would. So for the third example, if you view this source, you're actually going to see a lot more on the screen that's being sent down to the user. So not only do you have your application in your application container, but you also have your prefetched data in this as well. You'll also notice the app props are in here, and that's used for your client-side bundle to hydrate itself. Looking at this, and if you refresh this, it's pretty fast. The user sees something on the screen almost instantly. And I'll obviously take this with a grain of salt. This is the local host, but yeah. So just kind of some high-level recap of client-side rendering and server-side rendering techniques. Client-side rendering, you're not really able to see anything useful on the screen until React executes your app. And then with server-side rendering, you're pretty much able to see everything for that initial view. So the first load is very performant, and your user has something to look at while your JavaScript bundle downloads and React executes it. Just to kind of look at the network activity and what's really going on. For your client-side rendering example, you'll see that the document stays pretty static, so the file size is a little bit smaller. With your server-side rendering without data hydration, it's definitely a little bit bigger because there is markup inside of that empty application div. And then once the application is executed by React, an API fetches your blogs, so you have an extra 100 milliseconds for that in this example. For your hydrated server-side rendering though, the document size is about 3 times bigger, and it does take a little bit longer because you're making a database call, but you're sending all that down into the initial document, which should be more performant in theory. And then it doesn't actually need to make that extra API call because it has all of its data already sent down in the initial HTML. So kind of some pros and cons of using server-side rendering. You get consistent SEO compatibility, which is really big for us. User has a really performant first load. They almost see the entire application instantly. And the maintainability of a isomorphic or universal application. Some cons though, initial server response time can really increase. This can degrade server performance, especially considering how big your app is, because render to string is synchronous, I believe. All components that you create have to run on server side and client side. So if you rely on any window objects use cases in your components, you can't do that. And one kind of catch with server-side rendering is the user actually can't interact with the application until the JavaScript distribution is downloaded and executed and event-bound. But if you keep your bundles relatively small, it's usually not a problem. People usually don't click on the screen within 300 milliseconds, 500 milliseconds, whatever. But yeah. And then, so is SSR right for you? It's so hard to say, especially trying to implement this into a current project, because you have to take into account internet speeds, JavaScript bundle sizes, third-party APIs that you might be using, server load, and if you need SEO compatibility. And that's it.
You listed maintainability as a pro. I was surprised to see it on that side. It seems like you'd have to do some work.
So I'm not going to lie, it took me a really long time to get my setup right. But after that, it was just kind of like really a breeze. So yeah, so these are really basic examples. When you start having things like React Router, Flux architecture like Redux or Reflux, those can really start complicating your app. And it takes definitely some practice to hydrate it, but once you work out those kinks and get your bundles right, you really stop worrying about kind of the server side hydration, and we just don't really see too many problems with that anymore. So we don't really have to worry if we need to server side render something. We really don't have to worry about, is it server side rendered? Is it not? We have different techniques to kind of deal with that.
Cool. And can you go back to the last slide?
Yeah.
Where you end the pros and cons.
Yeah.
Oh yeah. Is there a way to detect when it's ready? You said people aren't really, touching it until in the first 500 milliseconds, but
Yeah.
it would be terrible. Like this site sucks.
Yeah. Yeah. Honestly, it hasn't been an issue for me personally, so I haven't looked into it too much. But if there is a lot of content on the page, usually the user won't click on it within, a second or two, or they'll re-click and then, maybe 500 milliseconds later, the event will be bound. Personally, I haven't had a problem with it, but I could.
There's no API that you can hook into to somehow know when it's done hooking up.
There probably is. The Hydrate does have a callback. You could maybe put something in there. I honestly haven't played around with it enough to know.
Gotcha. Okay. Cool. Let's give all our speakers a hand.
Oh, good question.
I had a question.
Yeah.
So you're doing that JSON injection into the on the window object, whatever.
Yeah.
Is that just to basically skip the first API call on load?
No. So, well, yes and no. So, whatever your client side bundle, that still needs to execute.
Right.
So whatever the hydrate or render or your render method did, that still needs to match exactly what your server side render to string method had. So if you injected, your home component with initial properties, you need to inject those initial properties on the client side as well for the HTML to make sure that matches up.
Right. So are you I assume you have some sort of component did mount check of that property, and you're using that to hydrate the component, or basically the application when it loads, or am I wrong about that?
So React will check for you in development, but it.
Oh, so you're not using it the way I thought you were using it.
Okay.
Can you show the component? Do you know?
Yeah.
What's that, underscore F props or something?
Oh, wait, you want to look at the property or?
Well, yeah, so you're setting the thing on window, and you're basically using that to make sure that when React renders that thing, it matches what HTML is already on the page, right?
Yes.
I'm curious how you're doing that, I guess.
So you want him to go into the component did mount fetch logs and see where it pulled that from?
Well, the fetch log is the API call, right?
Yes.
So how are you, I assume you're using that to skip the first API call.
Correct.
Reference that window variable.
Yeah.
Yes, that's correct.
So where are you using that, like app state, that window dot app state, or whatever you call that?
Yeah, so that's in my. So my third example. So in my entry point for my JavaScript bundle,
Yeah, okay.
that my browser will execute. Sorry, let me make this bigger. And, oh, there we go. Yeah.
How do you deal with things like assets? Like if you were to send HTML before like your fonts like were completely there yet? Is there a way to block rendering until just like I've seen a lot of SSR sites that load with like Times New Roman and then they flash to like the system font that is specified.
Um,
Can you like block rendering until certain assets are provided?
I honestly haven't looked into it. Any other questions?